Section 1.1 Basic Definitions and Terminology. The first thing is I want to recall back from Calculus 1 that y prime is the first derivative of the function y. That's called y prime, which is dy dx. dy dx, or you can write it as f prime of x. That means it's the derivative of y with respect to x. Okay, with respect to x. In general, when we write y equals f of x, x is called independent variable, or it depends how people usually write it down, but it's important to see what this means. So x is called independent, the independent variable, and y is called the dependent variable. Dependent variable. So what do we need to learn here in this section? This is basically introduction to differential equations. So what is a differential equation? I would start by defining a differential equation. I would say a differential equation is an equation involving differentials or derivatives. That's what a differential equation is. And in differential equations, there are two types of differential equations. One of them that we're going to be using called ordinary differential equations. We abbreviate with ODE, or partial differential equations. PDF, partial differential equations. There are two types. These are the types of the differential equations. What is ordinary differential equations? Those are the equations that contains only ordinary derivatives of one or more dependent variables. Remember, when you say dependent means y. Dependent variables with respect to a single variable, x, which is the independent variable. So this one contains ordinary derivatives of one or more dependent variables with respect to only one independent variable. Examples on this, let's say like x plus y dx plus 4x dy equals 0, or dm dx minus dn dx is 5x. So these are differential equations. There's only one independent variable, x. Or even if you want to put it a second degree, that's the second degree, d squared y dx squared minus 3 dy dx equals 7y. So that's another differential equation. All of them are with respect to only one independent variable. And you can have, as you can see, more than one dependent variable. Here we had m and n, but here we had only one y dependent variable and only one x. The other part, the partial differential equations, those are equations involving partial derivatives. partial derivatives of one or more dependent variable of two or more independent. See, not only one, but two or more variables. For example, the partial u partial x equals partial v partial y, something like that. Or 2x partial u partial x plus 3y partial u partial y equals u. That's another one. It has more than, first it contains partial derivatives, as you learned back in Calc 3, and also it has more than one independent variable. So you are differentiating with respect to more than one variable. In the first one was with respect to x and y, and the same thing with the other one, with respect to x and y. So those are called partial differential equations. The next thing is the order of the differential equations. What is the order? The order is basically the highest order derivative is called the order. So for example, let's say we have d squared y dx squared plus 6 dy dx to the 4th power minus 8y equals x. So what we do here, the highest order derivative, so the derivative here, it's 1, but here it's 2. So the first one is 1, the other one is 2. This is, we call first order. This is the second order. So it is a second order differential equation. Second order differential equation. So how about the one I wrote earlier? Say x plus y dx plus 4x dy equals 0. Equals 0. So what we can do, this can be rewritten as x plus y dx dx dy plus 4x equals to 0. Okay, so this is a first, it's kind of like we divide everything by dy, and that's how I got this. This is a first order differential equation. How about if we have another one? Let's say partial third derivative of u with respect to x plus second of u with respect to t equals 0. This is a fourth order partial differential equation. Partial differential equation. The next thing we need to learn is about how to classify differential equations. There are two different kinds of differential equations, either linear or nonlinear. Linear or nonlinear. So a differential equation is said to be linear if it's written, let's say ax y prime plus b of x y equals c of x, or let's say ax y double prime plus b of x y prime plus c of x y equals d of x. In general, this can go on and on. A sub n of x y y double prime is the second derivative with respect to x, dny dxn plus an minus 1x dy dx plus a0x of x, y equals g of x. So two things here to classify it as linear is that all these coefficients, all the coefficients depend only on independent variable x. All these coefficients, this, only on the variable x. See, all of them depend on the variable x. So that's one thing. And the dependent variable y, what should it have, the dependent variable? So first we write coefficients of y and its derivative are functions of x. Are functions of x. What else we have? That's first condition. The next one, we need to make sure that y and its derivatives are all of the first power. And I'll show examples on this. So let's say we have an equation in the form of, let's say as example 1, y double prime plus exy prime plus y equals sine x. Is this linear? Well, look at the coefficients in the front. So we have a 1 here, we have ex, a y, and 1, not the y, the 1 in the front, and sine x. All of them are functions in x, right? All of them are functions in x. And the power here, all of its derivatives are of the first power. So this is like power 1, right? Power 1. So this is linear. This is a linear. How about something like this? Y triple prime plus 3y y double prime plus y equals ex. Is this linear? Well, no, it's not, because this one is not in terms of x, not linear. Other examples. How about x squared dy dx plus y equals 7? Is that linear? Well, let's look at the coefficients first. X squared, 1, and 7. Everything is in terms of x. Even if it's a constant, that means 7x to the 0. So this is, yes, linear. And the degree of this is just 1, or the power is 1. How about something like this? Dy dx plus 3y equals sine x. Notice sine x is okay, the 3 is okay. But what happens this way? Dy dx, you can rewrite this as 1/2 and keep everything else the same. So what do we get here? The power is not first power, so it's not linear. It's not linear. Another example, y double prime plus sine y, or sine of y times y is ex. This is not linear because of sine y. It has to be only in terms of x. How about if we look at another one, number 6, d cubed y dx cubed all to the third power minus 5, d squared y dx squared all to the second power minus 3y equals 0. Notice the numbers in the front are fine, the coefficients are okay, but the powers are not. Powers not. Okay, so not linear. Last example in this, say x to the 4th d to the 3rd y dx cubed plus 5x dy dx plus 8y equals ex. This is linear, and try to convince yourself why. The next part in this section to learn about is they give you a differential equation. Differential equation is given. Let's say y prime to the 3rd power plus xy prime equals y. And you've seen some examples like this back in Calc 1 and Calc 2. So we have y equals x plus 1 given. So we need to prove that y equals the x plus 1 is a solution for the given differential equation. So how do you do that? We need to take that y and we need to find y prime, which is 1, and then substitute into the given equation or differential equation. So the left hand side, y prime is 1 cubed, x times y prime is 1. What do we get? 1 plus x, which is just 1 plus x. For the right hand side, it says it's y. But what is y? Y is given, x plus 1. See, they match. So you're fine. Same. We have this differential equation. We need to prove that y equals e to the 2x plus x e to the 2x is a solution. How are you going to prove that? To do so, we need to find y prime, which is dy dx first. This is the derivative of this is 2e to x plus, you can use product rule here, 1 times e to the 2x plus x times 2e to the 2x. So that gives us 2e to x plus e to x plus 2x e to 2x. We can add these together here. 3e to the 2x plus 2x e to the 2x. Then y double prime, which is the second derivative. It's 6e to the 2x plus, again product rule, 2e to the 2x plus 2x times 2e to the 2x. So that's 8e to the 2x plus 4x e to the 2x. So now we go back to the equation. The second derivative with respect to x, that's the one I found. That's the left hand side. And then it says minus 4 times the first derivative, 2x e to the 2x, plus 4 times the y itself, which is e to the 2x plus x e to the 2x. Let's see if we're going to get 0. We must obtain a 0. 8e to the 2x plus, keep this the same. Multiply this, 12e to the 2x minus 8x e to the 2x. Multiply 4e to the 2x plus 4x e to the 2x. 4x and 4x, that's 8, cancels the middle one. 8 minus 12, negative 4. With a positive 4, that gives us 0. So that tells us that this is a solution. So derivatives are very important, as I stated in class yesterday. Very important to know how to find derivatives for this course. And this is what this section is all about, is just introduction to differential equations, types of differential equations, order, linear, nonlinear, and how do you verify a given equation or solution is a solution to a given differential equation.